Hello everyone, in this video we're gonna take a look at a question called crazy fencing from the series CCC competition. So the problem gave you n pieces of tropsoid, and you have to calculate the total area of the fence, which consists of those tropsoids. So we can just use a linear algorithm to use our formula to calculate the area of tropsoid and sum the area of tropsoids up, and that will give us the answer. So just to do a recap, the formula to calculate the area of tropsoid is a plus b times the height divided by 2. So a is the upper base and b is like the lower base. So like 2 bases times the height divided by 2, and it just gave us the area. Okay, so let's code this solution. Okay, so just gonna load up the repo. We just include bits std c++.h. I will post like the solution of other language later, so in later videos. So using namespace std, so int main, we're taking the number of tropsoids. So our set1, let's take in the input of set1 first. Well, actually we can use 2 vectors to store the height, to store side lenses and height lenses. So side will be integers. It will always be integers because height is smaller than 100 and width is smaller than 100 as well. So let's so we have h and w. Actually, like here, w means the height. So let's just use the variables the question gave us. So we have n plus 1 and n. So okay, we have taken our inputs, and now let's calculate the total area. So to make the things a bit simple, we don't have to divide by 2 at this process. We can do it in the end. So we are treating this as a big rectangle, which has the twice area of each tropsoid. So we're just combine 2 tropsoids together to form a rectangle. So let's loop through. We'll create a variable to store the total area. Okay, let's make a variable here. Tot goes to 0. So tot plus equals to h I plus hi plus 1. So those are the sum of the side. So this side plus that side is of tropsoid is hi plus 1, and times the height. So we have wi, and that's our total area. And our answer is the area divided by 2, because those we are just calculating the twice of the actual fence area. So let's divide by 2 in the end. Tot divide by 2.0. So our answer might be a floating point number, like 0.5, 1.5, so we have to cast it to double or float, or yeah, just like a floating point number. So let's try to run our sample. Paste. Oops. I think the answer is 75. Oh, wait. Oh yeah, we calculate the second samples. So let's do this first sample as well. So the second sample gave us the right output. So let's try to run this first sample. And as you can see, it outputs the right answer. So let's put our code into the grader. Here you see there's like two wrong answer, and it's quite like obvious that we probably met some floating point errors. So we can handle it easily by setting the position of precision, or we can do it in another way, which is let's use if statement. So if tot divided by 2 times 2 doesn't equals to tot, then we just see out tot divided by 2 plus 0 plus 0.5 and int line. Otherwise it means otherwise we just see out the tot divided by 2. So this might be quite confusing, but I will explain this very shortly. Okay, let's try to run our sample again. Let's copy the sample. Okay, 18.5, it looks good. Let's run our solution. And now as you can see, the errors are gone. So I can explain how I did it, like how I erased the error. So in C++ and so is Java, the number operations, if you're doing like int operations, there's no floating. So if you divide something that end up a floating point result, like numerically, like on hand or on paper, but your computer doesn't do that. So if your numerator is an integer and denominator is an integer as well, then it will just cast the result to integer, so it will be automatically rounded down by 1. So if you have some result like 17.1 blah blah blah, so when the computer casts it to int, it will be 17. So here, if we divide by tot by 2, if that thing is like 18.5, it will be automatically cast to 18, and we times 2. So it won't equals to 18.5 times 2, or it won't equals to 37. Like, and then we know that our computer have casted to another number, like the integer below the actual result, and then we can plus the 0.5 in the end of tot divided by 2. So we can do this because the answer always gonna be an integer or an integer plus 0.5, and that's our strategy for this problem. So thank you for watching. Bye.